Subscribe to AmpCode and ring the notification bell to get the latest content.
Okay, so in this lecture, let's talk about how to set up a Spark cluster. So first, you should know about what is Apache Spark cluster. So as we already discussed in the architecture video, that Apache Spark is nothing but a distributed platform for processing big data. So Spark cluster consists of several worker nodes, or we can also call them as a data nodes, which works in parallel to process your big data with ease. So it consists of the master node, which has the driver program and also manages all the data nodes across the cluster. And the data nodes are nothing but the commodity hardware which can be easily replaceable and readily available, which actually stores the data and does all the groundworks to process that data. So once you submit an application on the Spark cluster, it gets distributed across the cluster in a smaller chunks of data, which is nothing but we can call it as a different tasks, and then it got executed and the aggregated output is given to the client. So this is how Apache Spark cluster works. So you already know about it, so we'll not go into much detail. Let's talk about the essential steps you need to follow to set up the Spark cluster. So the first thing is you have to choose the suitable cluster managers. So as we already know that Apache Spark runs on different cluster managers. So it totally depends on what your organization data platform is and what tools are readily available for you to be integrated with your Apache Spark cluster. So let's say if you already have a Hadoop ecosystem in your organization and your organization is leveraging Hadoop tools, then you can integrate it easily with Apache Spark and use Yarn, which is nothing but yet another resource negotiator for running and managing your Apache Spark. But if you also have like the Mesos or the Kubernetes, then also you can use those platforms as to manage your resources of your Apache Spark cluster. So Spark is all about the versatility. So it totally depends on what tools, what are your needs, and what resource managers are readily available in your organization's data platform. Then once you choose your cluster manager, then you have to set up your master nodes. So master node is nothing but a machine which acts as your master nodes. So basically on your master nodes, the first step is you have to install Apache Spark on that machine, and after that you have to set all the configurations. First thing first, you will set up a variable for Apache Spark home where your Apache Spark has installed on your system, and you can set all this configuration to set up your cluster manager in the spark env.sh file. Then you will be able to kick off your master program, or we can say start your master nodes in the sbin directory. So in the sbin directory there will be a file known as start-master.sh which will kick off your master nodes in your Spark cluster. Then once the master node is up and running, then we have to set up your worker nodes. So basically all the worker nodes will process the data and connect it in a parallel way. So basically for worker nodes as well, the first step is you have to install Apache Spark on all the worker nodes that are available. So once you have installed Apache Spark, you have to repeat the process of like updating the configuration, but you have to apply the master configuration on all the worker nodes in your Spark cluster. So this can be done in the spark-env.sh file, but also you have to set up your master URL by setting up a variable in the Spark master UI so that it will know what is the master node of your Apache Spark cluster. And then once this is all completed, then you have to kick off the file which is known as start-worker.sh present in the sbin directory. So this is how you can set up all your worker nodes across the cluster. Then also comes the configuring the Spark environment and the network setting. So basically network settings are pretty vital to maintain the communication of the RPC protocol, which nothing but is responsible to handle the communication between the master and worker nodes. So to improve that, you have to use the optimum network settings of your Apache Spark cluster to able to seamlessly handle the communication between all the worker nodes and the master nodes in your Apache Spark cluster. and also you have to configure the Spark environment variables as well to be able to set up your Spark cluster. Then the next step is you have to test your cluster. So for testing your cluster, there are like simple techniques by which you can effectively test your Apache Spark cluster. First is, let's submit a sample code or sample job in your Spark cluster and see if it runs successfully or not. So we can use like word count operation, where we will be counting the words present in a file using RDD operations, which is transformation, and the action, which gives us the count of all the words. So basically you can use that for testing your cluster, and if it runs fine, then you can move ahead to the all other testing scenarios. So also you can check the fault tolerance of your Spark cluster by intentionally causing a failure of your application and see if it continues or gets submitted on other available nodes to be able to get the accurate results from your application. Also you can check the parallel processing and the performance of your Apache Spark cluster by increasing the size of your dataset so that you will able to understand the capability of your Spark cluster. Also, as you already know that Spark comes with its Spark UI to monitor and debug your applications. So you can also test it and try to monitor and debug your Spark applications which is submitted to the cluster. So this is how you can test your cluster, and if it looks good, you can go ahead and start submitting your workloads on your cluster. Then comes the optimizing the cluster performance. So you can use the best ways for optimizing the performance of your cluster as well as your applications. So you can use right Spark memory configurations to able to limit the available memory for each type of applications, as well as there are several settings which will improve the execution time of your applications by vast margin. And also the last step would be like monitoring. You have to closely monitor the performance as well as the health of your Spark cluster, and to make sure that all the worker nodes are healthy and equally occupied with all the tasks that are available and submitted on the cluster. So this is how you can set up a Spark cluster very easily by following all these steps. We may be not going to see Spark cluster in action because we don't have access to all the commodity hardwares where we can install Apache Spark and they will act as a worker node, and we have the single machine which acts as a master node. So since we already only have our local machine here, we have already simulated how the Spark cluster works, and we have also seen how Ambari UI will give you the capability to kick off all this cluster, which includes Hadoop, Spark, and what's not on a single machine, but also gives us the capability to understand how these tools will work in the real production environment. So I hope you understood how to set up a Spark cluster. But also let's talk about all the deployment modes that are available in the Spark cluster in the next lecture.
So that's it for today. I'll see you in the next lecture.